Um, Not much to talk about on the first page. A lot of these are very similar to your quiz. Not as many though. I put one graphing, one substitution, and one elimination. You got a few more on the quiz. So you still got a little bit of that. Just same deal as the quiz. Just make sure you show me the work, like on the graphing, make sure you show me the lines. What happened on the graphing on the quiz was sometimes we didn't say what the solution was. So when it says solve graphically, your answer is either an ordered pair, tell me where they cross at, or it's no solution or infinitely many solutions, okay? So make sure you, based off the graph, tell me what the solution would be as well. Substitution, just show the work. On both of those, same as the quiz, the directions even tell you, you can use the graphic calculator to check, but I don't just want you to plug it into the matrix, because I know you can plug it in the matrix and get it, and that would be the easiest route to go. But if you want to do that to check it, that's fine. But I need to see the work for substitution and elimination on those two. On most of the story problems and things like that, I'm going to make it easy on you and let you use your calculator. But on those first three, show me a little bit of work there. On this one here, just remember there's only three types of solutions. So one of these does not fit. The one that never fits is the inconsistent dependent. So that's the one you can get rid of. It may not always be C, right? But inconsistent dependent is the one we don't need to worry about. Consistent dependent means infinitely many. Consistent independent means one solution. And inconsistent independent means no solution. So we just have to decide what type of solution or what type of system do we have. I think the easiest way to do that is just solve for y. Compare the two equations. So you got to do a little bit of work to solve for y, and then once it's solved for y, it's pretty easy to determine, because are my slopes the same? Are my y-intercepts the same? If the slopes are completely different, then it's one solution. If the slopes are the same, but the y-intercepts are different, that means they're parallel, so that would be no solution. And if the two equations are exactly the same, then obviously it's infinitely many solutions. So once you have it in slope-intercept form, it should be pretty easy to determine which one you have. Okay, a couple of different kinds of story problems here, and I'm going to kind of walk you through number 5, mainly because solving of this one, I'll kind of show you what I probably would prefer, and then we'll kind of talk about number 6 as well. On number 5, we kind of had one like this on the quiz, except the one on the quiz kind of gave us the equations, and we just had to kind of compare. This one does not give us the equations, obviously. And so we're talking about this company that makes plastic handles of some kind. So X is the number of handles, and that's the question being asked, is how many handles must be molded and sold weekly to break even? So basically we have two different equations here. We have the cost equation, and then we have the revenue equation. Cost is anything that is a cost to me, right? Or the cost to the company. And so it costs them 60 cents per handle. And then it's also going to cost them $4,192 per week. Okay, but we're just looking at the cost per week. So that's a one-time cost each week. That's how much it costs to run the machines, maybe pay their workers, whatever that is. There's a $4,192 cost to the company. And then they're going to sell the handles, so that would be your revenue, for $2.60 a piece. And that's my only revenue, okay, just selling the handles. Both of these are in slope-intercept form. These are your two equations. And I know that I've told you that matrices is probably our quickest and easiest go-to, but in this case, because they're both in slope-intercept form, I think the easiest route here is just to take this and plug it in for y right here. And so then you could just go 260x equals 0.60x plus 4192. And then you can solve for x from there. Once you're there, it shouldn't be too bad to solve. And we're solving for x, how many handles, and that would be like your break-even point. How many handles do I need to make and sell to break even? Number 6, a little bit different equation, but same idea. It's still a story problem. On something like this, because we have 2 different types of tickets that we're selling, you don't always have to call it X and Y. If you still want to call it X and Y, that's fine too. Okay. I like to use A and S because those are the 2 things that we're solving for. How many adult tickets, how many student tickets do I need to sell in order to make both of these things happen? So to start off with, we're going to have 2 equations here. Because we have 2 variables, adults and student tickets, then we're going to have 2 equations. Okay? If I had 3 variables, I should have 3 equations. And that's kind of the way to keep that in mind. Okay? The other equation is going to be what I just call my money equation. Everything is money in that equation. Okay, so tickets, I'm going to sell 2 types of tickets. So the number of adult tickets plus the number of student tickets equals my total number of tickets. Okay, has to be some combination that adds up to be 360. I could sell like 200 of one kind and 160 of the other, or there's tons and tons of combinations that would add up to be 360 here. Okay, and then the reason I like to do this is because the second one is only about money, and we know that $10 is what it costs for adults to go. So we're going to go 10A. And then students cost $7, so $7 times S equals the total amount of money that they made, which is $25.80. Okay. So just got to get the 2 equations set up, and once you're here, what would be the best way to solve this? Just put it in the matrix, right? So here, this would best be solved. And on any of the story problems, you can solve any way you want to. Okay, the only ones that you're restricted on are the first 3, where it tells you graphing, substitution, elimination. You can always do graphing, substitution, elimination. On this one here, we used substitution, but probably matrices is going to be our go-to majority of the time. And so that's what I would do there. And then don't forget, you got to put in the RREF and do all of that and solve it out. Be careful on some of these. This one's asking me for both, how many student and how many adult tickets were sold. So it's asking me for both. In some cases, it may only ask you for one or the other. So just read the question carefully on what they're asking for. Okay, on number 7, this is the only one that's a little bit different. And when we did it, I told you that we could do this by matrices, but I never really showed you the matrices method because I think putting it into the stat function is a whole lot quicker and easier. And so this would be the one that you have to put it into stat instead of matrix. Okay, so we're not going to put this into a matrix. The one thing that you have to do here, when we start off with a particular year, like 1950, I'm going to call that my year 0. That's like my beginning year. Everything started in 1950. Or collecting data or whatever it was. So we don't want to put in the actual years. We want to put in how many years have passed. That would be my X value. I put that in list 1. The population, I put that in list 2. Okay, and then we're going to go to stat. This is a quad reg equation because it says quadratic function. If you are on a Casio, it would be the x squared function. Okay, and it's going to give you 3 values of A, B, and C. And they are decimals here. A couple of you asked me about it yesterday, that they're big, long decimals. And so just round, and I don't really care what you round to. I'll be pretty lenient on your answer as long as your answer is pretty close. It'll kind of depend on what you round to, okay? And so I think I wrote on my key, I think I wrote or rounded to the nearest thousandth, just to make it a little bit more exact. So I would round the A, B, and C values out to the nearest thousandth, 3 decimal places. And then to finish it out, we're trying to figure out what it would be in 2010. Well, 2000 was year 50, or 50 years past. So 2010 would be another 10 years past. So then, once I have my equation, then I'm going to take 60 and plug it in for x. And then whatever you get there is your answer. Okay, also notice this population is in thousands, so this means the population of this town was 120,000 in 1950. And so all of those numbers are in thousands. And so when you write your answer, when you write the population of the town, if you get like 180,000, then you just, or if you get 180, then you'd write 180,000. So you just write it in thousands for the population. Okay, 8 and 9 are both very similar. 9, we had one kind of like that on the quiz. 8 is a little bit different. Both of these are going to be 3 by 4s. Okay, and on both of those you can solve. Thank you. You can solve by using your matrix. Okay. But you got to get the equation. The hard part of that problem is getting the equation set up. Remember, if you have 3 variables, x, y, and z, or whatever the variables you use are, then you're going to have 3 equations as well. Okay, so just remember, if you have 3 variables, you should have 3 equations. I know, like on the quiz, some people put like x, y, and z, but then they only had 2 equations. And so there should be a 3rd equation. And they give you information in there to help you set up 3 equations. (10) and 11, same thing. This is going to be a 3 by 4, put it in your matrix. This one's going to be a 3 by 4, put it in your matrix. Remember, we talked about yesterday, if we get a no solution or a mini solution, what does it look like? Infinitely many has a whole row of zeros on bottom. No solution would be like 0 and 1, or some other number here. You should also have a diagonal of 1s. If you don't have a diagonal of 1s, that's the key on those. Okay, 12 should be pretty straightforward. 13 and 14, given equations, write the matrix. Given the matrix, write the equations. There's not really any solving there, so those should be pretty quick and painless. And then in the last section, we spent a couple of days on this, and there's a lot of different types of problems. This one is simply just graphing an inequality, okay? One inequality. And so you're going to have one where you're going to graph one inequality, you're going to have one where you're going to graph a couple, and then you're going to have some story problems on here as well, like we did. When you graph this one, you can do it however you want, okay? I don't necessarily care the process that you go through here. Some people like to put it in slope-intercept form. Some people may like to just use the cover-up method, okay? We talked about using the cover-up method. Even when it's an inequality, you could do that. You could solve it for y if you want to put it in your calculator, okay? And so it kind of depends on where you want to go with it. If I did the cover-up method here, if I plug in 0 for y, x would be 5. If I plug in 0 for x, y would be 3. So 5, 0, 0, 3. Okay, then we decide what kind of line do we want. As long as it's equal to, it's going to be a solid line. If it was less than or greater than, There'd be a dashed line. So there would be our line. And then we have to decide where are we going to shade it at, okay? And no matter what method you use here, whether you solve for y or whether you put it in the cover-up method, then I always like to check with a point. 0, 0 is always my go-to because using 0, 0 should be a piece of cake. So I'm going to go -3 times 0 minus 5 times 0 is less than or equal to -15. And I like 0, 0 because it's a piece of cake. 0 minus 0 is still 0. 0 is less than or equal to -15. Is that a true statement? Is 0 less than -15? No. Okay, so 0, 0 right here is a no. That is not the side we want to shade, so we want to shade the other side, okay? And that's how we kind of decide where to shade at, okay? And I show you the checking part here because here's probably the part that most everybody misses on this. We look at the symbol less than, and I think, okay, I'm going to shade below because it's less than, right? But the reason why it's shaded above the line is because if I were to solve this for y, I would have to divide by a negative, and that dividing by a negative makes that sign flip, okay? And so if you solve for y, you might actually see that. You got to remember, if you solve for y, you got to flip that sign as you do it. You don't necessarily have to solve for y, but if you don't, then you have to check it. You have to plug in a point in 0, 0. As long as the line doesn't go through 0, 0, you can always use 0, 0. If it goes through 0, 0, then that makes it a little bit different. Then you'd have to pick a different point. Okay, so there's nothing that you need to put on that one, just graph it, okay? That's your answer. The graph's your answer. Okay, you can put this one into your calculator, but you probably don't necessarily have to. If you did want to put it into your calculator, remember that absolute value button is kind of hidden. On TIs, you got to go math, num, AVS. For Casios, you got to go a little bit different direction. But you could probably do this one without putting it into your calculator. Because what does, when the -2 is on the inside of the absolute value, what's that going to do to my graph? What direction is it going to move it? Right to. Okay, and so we know here that this graph is going to go right to. The bad thing here is all of those graphs have moved right to. This is just a multiple choice question. Okay, then I got to decide, should the graph open up or should the graph open down? Well, there's no negative out in front. If there's a negative out in front, then we're going to flip it upside down. Okay, so immediately I can eliminate A and B. Those two are gone because those open down. We want one that opens up. And then we got to look at the sign. Okay, the sign is less than or equal to. So that's going to be below the V instead of above the V. And so C would be the one that we want. So that's how you can kind of use process of elimination. Okay? If you want to put it in the calculator, you can, but I think that'd be kind of the way I would go about it. Okay, 17, your vertical line is your X. It crosses the X-axis at -4, or +4, sorry. It crosses the Y-axis, or the Y values at -4, okay? Because that Y is the same as we're going above and below, okay? And you might say, well, this is the X-axis, but remember, if I have a horizontal line, it's always going to be my Y value. So this is going to be Y greater than -4. There's a dashed line there, so really pay attention to that line. It's not solid, so we don't want an equal to. And then for my X, it's going to be to the left, so it's less than, equal to because it's solid line, +4. And so then we just got to decide which one of those matches up with it. 18 is doing the same thing, except it only has a y. And so we're going to go up 3, make a solid line because it's less than or equal to 3. Negative 4, we're going to go down 4. That one would be a dashed line because it's just less than. And then it's going to be between. Y is between negative 4 and positive 3. And that would be my graph. Okay, if it was x instead, it would be 2 vertical lines instead of 2 horizontal lines. Okay, on number 19, one of the key things here is they're going to ask you for the vertices. There's no profit or max min function here that you have to plug it into, but I do want you to find the vertices here. Okay, and I'm going to give you a hint here. It's going to make a triangle. It's going to be 3 points that you're going to be looking for. We did some the other day. One was like 4, one had 5 points, so the number of points is always going to be different. This one has 3 points, so you're looking for 3 ordered pairs. When you do this one, also, if you're going to plug this into your calculator to find like the intersection, then I just want to make sure that you're careful about how you do this. I would always put x in front. Otherwise, your order pairs are going to be flip-flopped. And you will need to find the intersection. And so when I put it into my calculator, we're going to put this in as a 2 by 3, and that'll find the intersection of those 2 lines. But you want to make sure x is in front. So it just kind of has the equation written backwards. Also notice that y greater than or equal to 0 is a horizontal line, kind of like we talked about just a second ago. It's a horizontal line, so it's above the x-axis. Okay? There is no x greater than or equal to 0. So we are not limited to the first quadrant here. We're limited to above the x-axis. This only has one of those inequalities. A lot of them that we did had x greater than or equal to 0 and y greater than or equal to 0. This one just has the y greater than or equal to 0. So you can have a shaded part in the top half of the graph, either quadrant. Okay, on number 20, and I'll give you these same instructions tomorrow, but you don't have to do the vertices on this one. I know it doesn't have any instructions on this page, so I'll make sure you guys are aware of what you need to do. All you need to do is graph and shade. Because it has inequalities, then we're going to graph and shade. Okay, these last two are both very similar. Number 22 does not have a graph provided, but you're going to do basically the same thing as number 21. Graph the inequalities, find the points, and then plug it into your max min function and figure out what your max and min is going to be. The only difference is 22 is a story problem, so you're only finding the max, and 21 you're going to do both the max and the min.